Hello, this is ITS148, and today I'm going to do programming project 16.4. So let me share my screen. And we are in chapter 16, and I'm going to do developing efficient algorithms. I'm going to do 16.4 today. So if we look at 16.4, it turns out that programming project 16.4 is it's figuring out something called a convex hull. So if we look at the problem, it looks like this. And basically we are, you enter in a bunch of points, and you're supposed to figure out which, connect the points that'll completely surround all the rest of the points. So all the rest of the points are on the inside. So if we actually, let's go back to the table of contents and let's go to where it explains how this works. 16, this finding a convex hull. So basically, we start out with a bunch of points. Here's an example here, if I can make this a little bit bigger. We have a bunch of points here, and so we draw a line starting with the bottommost point. The bottommost point, and that is y is the of all the points, the point that's got the lowest y, value. That's going to be a point. And then we start by looking to the right, and we find the first point moving counterclockwise. So let's see, what's a good way I can show this? Let me bring up the whiteboard. And let's say we've got a bunch of points like this. We've got a bunch of points. Okay, so these are a bunch of points, and so we start by finding the point with the lowest y value, and that would be this point right here. This point is going to be part of our convex hull. It's a connection of dots that will surround all the points. So we start by looking at the bottommost point, and we can draw a line. You know, we're going to go this way, and then we're going to go counterclockwise around this way, and each time finding the first counterclockwise point we come to, and that's going to be the next point in our hull. Okay, so if we look at a line here, and then we look at the rest of these points to make a triangle, we see that this point here, if we move this line up, the first counterclockwise line that hits is this one here. So see, if this goes all the way out here, then this one is farther on the inside. So this point is going to be in our hull. And then from here, we go counterclockwise this way, and this is the next point in our hull. And then from here, we go counterclockwise this way, and we go and it looks like this is the next point in our hull. And then we go counterclockwise this way, and it looks like this is the next point in our hull. And then we go counterclockwise this way, and it looks like this is the next point in our hull. And then we go counterclockwise this way, and it looks like this is the next point. And this point is already in our hull, so then we know we're done. So our hull is this point, this point, this point, this point, this point, and this point. Okay, so that's how this was built here. This point to 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 this point. And so the way we figure this out is, now there's lots of different ways. Okay, here's something you can fiddle with. If you do the left mouse click, it adds a button. It adds a dot. So here we're going to right. Yeah, the left mouse button adds a dot. And I want to sneeze again. Excuse me. This one, if I do my right click, that removes it. So you can see that this sort of remakes the hull. All right, now it talks about this gift wrapping algorithm, and I read through this, and I think there's some errors in this description. I think this should be P, for example. And so what I did was I searched the web, and I searched for computing convex hull in Python, gift wrapping algorithm in Python, and I found this computing convex hull in Python. And this guy talks about how he did it, and he kind of goes through a story here, and he uses this this clockwise algorithm. Was that in this one? Clockwise algorithm. And so he actually his algorithm actually builds this thing going to the left. So he builds it first this one, then 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 this one. So he's going clockwise around this thing. And it turns out that when I wrote this program and I tested it, it doesn't like clockwise. So then it's easy to switch it to counterclockwise. So that's what I ended up doing. Now, the way that I figured out if something is the next point, the next point when you're going counterclockwise is, see, let me try to erase some of this stuff. Let me just clear this out. Is we have some points here. Like that. It's I find the point that's got the lowest y, and let's assume that there's another point right here that's the lowest y. So let's say that there's 2 points here that have the lowest y. I take the lowest y on the right. I take this lowest y, okay, not this one. And that way, let's see, is that right? I don't think it matters, actually. So anyway, I start with a y, and then I'm going to test, since I'm going this way, I know that I draw a line back just one point, and so I've got a horizontal line here, and I know that the next point is going to be somewhere in an angle that's starting from here going up. Okay, now and so what I'm going to do is I'm going to test all of these points to find out which angle is the greatest angle. Okay, so for example, this angle, and it's the greatest angle from this line here. So this angle is less than this angle. Okay, so I'm testing all these points, and I want to find which point causes the biggest angle from A. So I've got a point A, and I've got a point here, and I've got a point here, and that's going to make a triangle. Okay, and I want this angle. So for each of these points, I compute the angle from from here to here, from here all the way to here, from here all the way to here, and I find the point that makes the biggest angle. Okay, so starting here, from here to here, I try all these points, and I save the one that's got the biggest angle, and that is the next point on my hull. Okay, so and then so this is going to be the next one, and then I look at all the other points, and I find the biggest angle from here going this way, and it's going to be like this one here. And then I got a line here, and I'm going to find the biggest angle from here, and it's going to be this one here. And so each time I find a new point, I find I test the previous point with the current point with all the new points, and I find the one that causes the biggest angle. And then that's the one I keep. Okay, so that's my algorithm. And I sort of read that from reading this guy's algorithm, except for he goes the other direction. All right, so let's see. Okay, now, so that's what a convex hull looks like. That's what convex hull looks like. Now, it turns out that if we go back to our the questions in the back of the book, or in the back of the chapter, turns out that if we go back to programming exercises in the back of the book, this project 16.4 is exactly the same as programming exercise 16.11. So with that, we can 16.11 is this one here. See, it's the GIF wrapping algorithm. And what we do is we write this program, and inside the program there's going to be this method called get convex hull, and it's going to input the points, the collection of points, and it doesn't matter the order or anything, and then this is going to produce a list of points that in order make up the convex hull. So for example, here we input 1 point, 2 points, the third point, the fourth point, the fifth point, and the sixth point, which is 5.59. This is x is 5.5 and y is 9. And then it's going to output the convex hull. So it's going to start out with the bottom point, and this is where y is the lowest. So of all these, the lowest y is 2.0, which is this point. It's got 2.0. It's the smallest y. So that's the first one. And then going to the right, it's going to be, it turns out that 2.4 is the next one up. Turns out that this is the next one up. You see that y is just a little bit bigger, and it's this 6.24 is to the right of 2.5, 2.0. There's another low y, which is this one. The first point here is a low y. It's the same as this y, except for this xy is on the right, And this xy is on the left because x is 6 here. I know the first one, x is 2. So it turns out that, you know, to the right it's going to be this one, and then we sort of go around the block of dots, the mess of dots on the outside, going counterclockwise, and we end up back with this at this 1 2.4, which is the, you know, all the way around on the other side. So so the first thing we want to do is we want a program that can tell us what the angle is given the 3 points of a triangle. And so what I did was I searched how to compute angles from the points of a triangle. Okay, how to compute angles from the points of a triangle. And I found a good reference, this one here, that's Socratic.org, law of cosines. Okay, so here this gives an example. We have 3 points. That's going to be like, see, let me find a picture. Is there a picture of this someplace? Well, let's just go back here. Let me erase all this. So let's say we've got a bottom point down here, and then we have we have another point here, and we have another point here, and another point here, another point here, and here, and whatever. Okay. So we start out. Okay. So what we want is, when we start out, we're going to start out with this point here, and I have to start out trying to find the angle right here, the angle from here, this angle. It's either an angle to this point, or an angle to this point, or this point, or this point, or this point, or this point. And so we're going to try all the points, and we're going to find the one where the angle is the biggest. Well, and it's biggest from a line like that. So this angle from here, and so I start with saying that the first triangle I'm looking at is this point, and this point. Okay, and so it's this triangle, this is the triangle, and so it's this angle here. And I test that, and that's going to be a pretty big angle. That's almost 180 degrees. 180 degrees is all the way to here, but it's not quite 180 degrees because it's not quite all the way here. It's a triangle, so it cannot be 180 degrees. When you add up this angle and this angle and this angle, you get 180 degrees. Turns out. So so I have this point, which I'm going to say is my point A, and I'm going to say this is my point B, which is the point I came from, and this is my point C, which is the point I'm testing. So I've got a point B and a point A, and I'm going to test this one, this one, this one, this one, this one, and this one, and I'm going to find out which one gives me the biggest angle here. And so if I use this program here, it is, and I say it's A that is my current point, B is my last point, and C is the point I'm testing. Then I have this here shows me how, if I got 3 points, how you find the angles. This is the angle at A, this is the angle at B, and this is the angle at C. Okay, so I'm interested in the angle at A. Okay, this is where I was, B is where I was, A is where I am right now, and I'm going to test to see what kind of angle I get if I go to C. And so what kind of angle I get at A if I go to C. See? And so to do that, we use this distance formula. Now here again is we're the programmer. we don't really need to understand why these formulas work. We only have to know that, first of all, we have to believe that they're correct, and then we have to write code that can calculate these formulas. That's all. So we got to translate this thing into some Python code. If you read through this, we're going to use the distance formula, and the distance formula here's using the distance formula. This is computing an A, and it's going to, and this 4 and 3 is the first B and the first C, and 6 and 5 is this 6 and this 5, and so on. Okay, so we're going to calculate this. We're going to use this law of sines thing. You'll see how we do that. And basically what we end up with is we're going to figure out it's A. We want, this is A computing to 6533. So the angle at A for this is 65.22 degrees. The angle at B is 55.3 degrees, and the angle at C is 59.47. We don't care about the angle at B or C. In other words, we don't care about that angle, and we don't care about that angle. We only care about this angle. This is the angle at A. And so it's this one. It turns out that we want to compute this. This looks like it's the cosine, something called the cosine of A, and that's that number. And if we take the cosine of A, we take the inverse cosine of A, that's called the arc cosine. No. Oh, if we take, okay, so we find the cosine of A, and it's going to be that. From the calculations, from these A, B, C calculations, which we're going to calculate up here, these are the numbers. These 4, turns out this is -3, 6, 5, 0, 1, 3. That's these numbers here from the coordinates. And so we plug all those in, do the square root, everything. We get these values for A, B, and C. And then these values for A, B, and C, 50, 41, 45, they plug into this formula for the cosine. This is 50, 41, 45, and square root, all this kind of stuff. And you do this calculation, and you get this value here. This value is the cosine of A, and then you're able to take what's called the arc cosine of this thing, and we actually get a degrees. That's what we want. We want degrees, okay? We want to find the angle with the biggest degrees, okay? When we're testing from here, when we're testing these points, we want the one with the biggest degrees, and that's the next one in the hull. And then from there, we're going to go, we're from here to here. We're going to want the one with the biggest degrees going this way. And if that looks like it's going to be, it would be this one here. Okay, so let's write. Let's see. First of all, let's calculate this A, B, and C. We got to calculate this A, B, and C from the coordinates. So we have, let's put this over here. So let's start by default. First, we're going to import math because we're going to use the cosine function, maybe arc cosine. We're going to use the square root function. So let's import math, and then I'm going to create a function which is going to return the angle. Okay, so I'm going to say define, and I'm going to name it angle, and I'm going to say I've got an input of A, and I'm just going to do. We have an A0. And an A1. I'm going to call it this. I'm going to call it an AX and an AY. And we have a a bx and a by, and we have a cx and a cy. Okay, so those are the points that are coming in, and those roughly translate to this point is ax, ay, and this point is bx and by, and this point is cx and cy. So we're going to test all these c's, and each time we test, we're going to compute the angle here, and we're going to save the one that's the biggest. We're going to remember the one that's the biggest. So this function here, this method is just going to compute the angle, a line that goes from here to here to here. Okay, so I guess it's kind of crooked. It goes from B to A to C, and so it's from B. This is where we're from. This is where we're at right now, and this is we're testing where to go. Okay, so let's compute this A, B, and C, because we got to eventually get down to use this formula here, this formula, cosine A. So we need to compute A, B, and C. By the way, this should be B squared. This should not be B2, it's B squared. So we want to compute A, B, and C, and so we can use this formula to compute this. And then once we get this, we're going to be able to use this formula, or this one here, and to figure out what the actual degrees is. So let's compute this A, B, and C. That would be A, B, and C here. It's this one. Okay, so we have an A. A equals, it's going to be, and we can just write this directly. Okay, this 4 looks like it's BX. This 3 is CX. See, it's minus, and a minus makes a plus. And then the 6 is BY, and this 5 is CY. See, it's the 2x. It's the x. It's we're squaring this, so that means it doesn't matter if we take x1 minus x2 or we take x2 minus x1, because it's going to be negative of the other. But when we square it, it ends up being positive anyway. So it doesn't matter if we take x2 minus x1 or we take x1 minus x2. Same here, because since we squared. So A is going to be the square root, math.square root of, it's going to be bx minus by, this value squared. We can do star 2, and we're going to add to that. Oh no, I'm sorry. This is CX. BY minus CY to the power of 2 squared, and that's just, we just close this. Yes. So this is A, the square root of this squared and this squared. Okay, so that's A, and B is going to be B is going to equal math.sqrt of AX minus CX to the second power plus AY minus CY to the second power. And C is going to equal math square root of AX minus BX squared plus AY minus BY squared. Okay, so now we've calculated A, B, and C. And now we want to calculate this cosine of A. So that would just be, I'm just going to call it cosine of A equals, it looks like it's B squared plus C squared minus A squared. That's this top part. B squared plus C squared minus A squared divided by the bottom, which is 2, and I'm going to put parentheses in here, 2 times B times C. Because really, you want to calculate this, then you want to calculate this, and then you want to divide the top by the bottom. So first we're going to calculate this, and then we're going to calculate this, and then we're going to divide the top by the bottom, and that gives us cosine A. And then we want to take the arc cosine of cosine A. And so that is, I'm going to call it arc cosine A is equal to math.acos. That's the function name, arc cosine of cosine of A. Okay, but that just gives me some number in units called radians, I think. And so we need to convert that to degrees. Well, that's easy. We can just say degrees equal to math, and there's a math function for that. Degrees of arc cosine A. So this is going to be the angle. This is going to return the angle. And so let's just test this. So I'm going to input, I'm going to say points equals input, enter coordinates. Enter AX, AY, BX, BX, BY, CX, CY. And so I got to split them up. I got to say P equals something like it's going to be float X, some value V, 4V in points split. And I'm just going to split with spaces. Okay, so I'm going to put spaces here. Okay, so that does that. And I'm going to find what the angle is. Print angle of P0, P1, P2. This isn't very efficient. P3, P4, P5, whatever. So this function takes A, B, and C, computes what the angle is at A, and so that's this function, And so you're going to type in AX, the two coordinates for A, X and Y, B, X and Y, and C, X and Y. And this is going to split them up because they're strings. This is going to split them up into separate strings, and this is going to convert them into floating point numbers. And so it's going to be an array or a list P with six elements. The first two are going to be the coordinates of X. The second two are the coordinates of, coordinates of A, the coordinates of B, and the coordinates of C. Let's see what this looks like. And to test it, I'm going to use these numbers here. I'm going to use these numbers, and I should get this value. Yeah. So let's see what it looks like. Python test.py, enter in those numbers. I'm going to say 1 space 0 space 4 space 6 space minus 3 space 5, and I get none. Well, I'm going to do this, print P. Second, third one, angle. Oh, I don't return, I kind of return degrees, return DEG. I got to return the value. Stupidness. Okay, let's run this again. 1, 0, 4, 6, minus 3, 5, and I get none. Okay, I'm gonna 1, 0, 4, 6, minus 3, 5. Oh, it gave me an answer. I bet you I didn't I bet I didn't save it or something after I pressed return. So anyway, so I got an answer this time, 65.22 degrees, which is the right answer. See, 65.22. All right, so so it looks like that our angle function is working correctly, and so now I need to write a method that's going to return. It's going to input all of the points, and it's going to find the point that's got the lowest y value. So let me change this to enter in the points. I'm going to call this input string, and I'm going to say enter the points. Enter the points. Enter pairs of points. And then I'm going to say input coordinates. I'm going to change these to floating point. Input string. Split that, and I'm just going to call these see, I'm just going to split this first. I'm just going to split that into an array P, an array of coordinates. I'm going to say input coordinates. And so this is a bunch of input coordinates from the input string, and this is just one big string. This is as many little strings as there are twice the number of points that were entered. And then I want to I'm going to make an array of points. So it's going to be an array of points. Points is going to be an array. It's going to be an array, and inside there's going to be it's going to be one point float. Put this for x in the range of input, length of input coordinates, length of input coordinates divided by 2. So I'm going to go 2. So it's going to go 1, 2, 3, 4, 5, and then I'm going to multiply that by 2 to get the coordinates. So I'm going to go this divided by 2. That's going to be the range. So it's just going to go up by half. I'll tell you what, I'm not going to do it that way. I'm going to do 0. Well, this is fine. I'm going to do it this way. And so this is the range, and I'm going to get 2. This is an index. This is an index. I'll make this I for index. And so it's going to be float of input coordinates I times 2 comma n float input coordinates I times 2 plus 1. Okay, so this might be a little confusing. So this is a, I'll close this. So this is a pair. This is a pair. It's a pair of input coordinates, whatever is at 2. So this goes like this. Let me erase all this. So this is like 1, 2.4. I'll put commas here. 2.5, comma 2, comma 1.5, comma 34.5. Okay, so this is going. So let's say there's 1, 2, 3, 4, 5, 6, 6. There's the length is 6. So this is going to count. The range is half of that. So it's going to count from 1 to 3. So the range is going to be 3. The length of the number of coordinates is 6 divided by 2 is 3. So the range is 3. So I is going to go 0, 1, 2. Okay, because it goes from the range is 3, so it goes 0, 1, 2, and so 0 times, and this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5. So this is 0 times 2 is 0. 0 times 2 is 0. 0 times 2 plus 1 is 1. So So index of 0 is going to give us index 0 and 1, and then this is going to go 1 times 2 is 2, and then 1 times 2 plus 1 is 3. 2 times 2 is 4. 2 times 2 plus 1 is 5. No, this is going to be, sorry. This gives you that and that one, and this one gives you that and that one. All I'm doing is I'm incrementing 0, 1, 2, and it's going to give me index 0, index 1, index 2, index 3, index 4, index 5. Another way to do it would be to go arrange from 0 to the length of coordinates minus 2 every other one. So this is going to go 0, 2, 4, and it's going to not do 6. 0, 2, 4. And this would be like this. So this is going to do 0, 2, and 4, because it's going to go from 0 up to the length of coordinates is 5, minus 2 is 3. So it's going to do 0, 1, 2. No, what? The length of the coordinates is 5 divided by 2 is 3. So the range is 0 to 3, skipping every other one. So 0, 2, doesn't look like it'll go up far enough. Five minus 2 is 3. 0, 2, 4. Yeah, I think this is, I don't think this is right, actually. Yeah, I think, let's do it the way I was doing it. It's going to go from 0 to 3. The range is going to be half the number of coordinates. So instead of 6 coordinates, the range is going to go to 3. So 0, 1, 2, and 0 times 2 is 0. 0 times 2 plus 1 is 1. And then when I is 1, then this is going to be 2, and this is going to be 3. And when I is 2, then this is going to be 4, and this is going to be 5. And that covers all of them. So there's going to be 3 sets of points. Each set of points has got 2 values in it. It's got an x value and a y value. And there's in this example, there's going to be 3 of them in there. Okay, so anyway, so now that we have a set of points, we can we want to figure out what the lowest point is, the point with the lowest y value. So let's create a function a method called define lowest, and let's do lowest lowest left, I guess. Yeah, lowest left of all the points. Okay, so it'll be the lowest one, the lowest y value, and if there's 2 points that has the same lowest y value, then it'll be the one on the left. It'll be the one where the lower x valued one, the lowered x valued one. So I'm going to start out by saying x is equal to, I'm just going to start this out by saying x is equal to points, the first point, the x value of the first point, and y is going to be the y value of the first point. The y value would be this one. So x is going to be the x value of the first point, and y is going to be the y value of the first point. So that's just to initialize it. And then it's going to go through all the points, and if it finds one of the lower x, it's going to replace it with that one. And if it finds another one with the same lower x, its lowest y value, it's going to take the smallest, one of the smallest x. So for each point in points, if point of, okay, so point 0 is x and point 1 is y, right? So if point 1, that's the y value of this point, if that is less than what my current lowest y is, I'm going to call this lowest y, low x and low y. If this current point is lower than my low y, then I want that to be my new point, my new lowest point. So I'm going to say if that's true, if this is an if that's true, then I want to make my new low x equal point of 0, and my new low y equal to point the y value of the point. Okay, so that's if the y is lower. Now there's also the case where else if a point of 1 is equal to the low y, but also the point, the x value of the point we're looking at is less than the low x. So this is like we find, this is like we got a bunch of points like this, and the low y, there's two low y's. Okay, there's a bunch of points inside here, and we're supposed to find, you know, this. So this is the case where there's 2 points with the same low y. Well, one of them is going to have a lower x. So this, in this case, this is what we want our starting point to be. So that's this case here, and in that case, we would want to set our low. Our low y is already equal to 0.1, but our low x, we have a new low x. Okay, so, and we already have our low. We can do this again if you want to. It's already equal though, because it's already equal. So, so that saves that. And at the end, we go through all the loops, and then we return our low, low x and low y. As a point. Okay, so this is going to return a point, lowest left. All right, so once we have this method, we can actually write our get convex hull program. So let's try to do that. We actually should test this. Let's print. Excuse me. Here we're printing all these points, and then let's print. let's print lowest left points. All right, so I'm going to run this. What doesn't it like? One. Wait, am I? Let's see. I'm going to do this just in case. I don't think that's it, but it's got to be an integer divide. Oh, this is, I'm on the wrong one. For VM. Oh, wait a minute. This is nothing. I don't need to do this. What am I doing? Got to look at the right one. This is better. Okay, so I'm going to enter a pair of points. I'm going to enter in, let's see. This. All right, I'm going to copy this and I'm going to paste it here so I have it. All right, so I'm going to paste this in. These are some points. Paste them in here. And I should get, this is the lowest Y valued point. Okay, great. That is the lowest Y valued point. Okay, great. So that works. This lowest left works. And what happens if I put in, this is X of 2. This is X is 2.5. What happens if I do 1.5, 1.5, no, 2.0, 2.2 space 2. So that's another one on the same line. It should give me that one. Yes, it does. Okay. So so that works. So let's try to write our convex hull program now. Def get convex hull, and it's going to input a bunch of set of an array of points, a list of points. So I'll start out by making my hull list empty. And I'm going to say, I'm going to make my current point equal to my lowest left, this, of points. So now I got my lowest left points. And I'm going to make the last point so I've got this lowest left that's right here. And to set this off, start this out right, I'm going to make last point be just like right here. Okay. So it's like, so I'm looking for the biggest angle where from here over to here. And that's going to be 180, I believe. I think it's going to work. So this B, this is just to initialize B, okay? Because I don't know what this value is. So I'm just going to put it over here. It's this next point is going to have to be either y is equal or y is larger than this. So it's going to be up this way somewhere. So the biggest this angle can be is 180, but it's probably, but so let's so I have my current point here, and so now I got to set my B, my last point, which is just to initialize it. So I'm going to say last, I'm going to call it last point, and that's equal to current point, and I want a whole new copy of it. I don't want last point to be equal to the same object as current point. I'm going to create a new object, so I'm going to do it this way. So this is a last point is a list. It's a list which is a set of points. It's a set of values which make up a point, it is the two values that are in here. Now this last point is now equal to current point. So in other words, if this is current point, this is also last point. But I want to make it the x value to be less, a little bit smaller. So I'm just going to say last point, the 0th one, which is the x one, and I'm just going to subtract 1 from it. Equals last point 0 minus 1. So whatever these units are, it's just going to be 1 over to the left. So this is my one side of my triangle, and then the next side of my triangle is going to be this, which is current point, and then the first point that I'm going to try all these points, and I should end up with this point here, or in other words, my lowest point right now is my current point right now is going to be this one if I use this set of points. And my last point is going to be, it's going to be not 2.2, but it's going to be like 1.2, comma 2. And the first point that I find should be this one, 2.5, comma 2. So anyway, so now I've got a last point and a current point, and I'm going to do while current point is not in hull. Well, that's the case. I'm going to append a current point to hull to start out. And let's see, I need a biggest, so now I'm going to loop through all the points and I want to find the biggest angle. So I'm going to have a variable called biggest angle, which I'm going to keep track of what the value of the biggest angle is. So I'm going to initialize that to 0 because it's going to be bigger than 0. Better be. And I'm going to say my next. I'm just going to say my next counterclockwise point. Big long variable name there is. It's going to be something. So then I'm going to try for all this. So I'm going to try all the points in my set of points. Try every one of them, and if this the try point that I'm trying out is not equal to the current point, so I want to ignore the current point. In other words, I'm right here. I want to try all the points in the set, but I don't want to. But I don't need to try the current point. I need to try all the other points in the set besides this one. Okay, so that's why I want to exclude the possibility of I'm testing current point with current point. I don't want to do that. So now I want to figure out what the angle is between last point. So I'm gonna compute the angle. And it's going to be, the angle is going to equal to the angle of current point, which is current point 0 and current point 1. Probably an easier way to do this, but I'm just doing it this way. So that's the current point, and the last point is last point 0 and last point 1. And I'm trying this one, 0, comma, try point 1. So this is my current point, this is my last point, and this is the new point I'm trying. Okay, so and that's going to give me an angle. And then I'm going to see if that angle that I get back is bigger than the current angle that I've got so far. If angle is bigger than current angle, the biggest angle I've got so far, if that's true, then I got a new biggest angle. And I have a new point. Next counterclockwise point is equal to try point. And I can do it this way because it's both values of try point. Okay, and and after I have after I finally found the next counterclockwise point, once I've done that, then I can shift. When I'm all done with all the points, my last point is now going to be my current point, like that. And my current point, my new current point, is going to equal my next counterclockwise point. And when I'm all done with the while loop, I return hull. I just return it. And it'll be a list of lists because here, this is the point. This is a point. It's got two values in it. It's a list with two values, an x value and a y value. And so that's a point. And then I'm going to append that onto this hull, which is also a list. It's a list of points. And so so each time I find the next counterclockwise point from the current point and the last point, I grab it. It's going to be the one with the biggest angle. And so let's see what this does. So let's run this, and I'm going to use this data here. 4 tri-points on line 34. 4 tri-points in points. Yeah. Okay, paste all them in there, and we should get the, oh, I didn't print out hull. Okay, so this is the lowest one. That's all we did, we print out that. Okay, so now I gotta print out lowest left, and now I'm gonna print out hull. Print hull. Oh, print this. This is points, whoops, points. So this is actually gonna print it out. All right, let's see what this does. List index out of range. Low X. I think I was copying the wrong thing. Let me just try this again. Enter points, and I want to enter these points here. Copy, paste. Okay. Get convex hull. Current point equals lowest left. Spellings point. Current, this is on line 27. Lowest left points. Okay, this should be points. Okay, let's try this again. Okay, if tri point is not defined, try points. Try point. Yes. Gotta spell everything right. Okay, so what is all this? Why is there so much here? What am I printing out? Where am I printing? I must be printing some stuff here. Okay, the problem is I have this print statement still up here. Let me get rid of that. Now let's see what this looks like. Okay. And we end up with 2.2. Okay, so that works. And then this goes around. 6 is x. Yeah, okay, so this goes around counterclockwise. Okay, now we should be able to just take this code and I'm going to comment out. I'm going to comment out this. Comment out this. And what happens if I copy this whole thing? I'm going to copy this whole thing down to here, and I'm going to copy it and go over here, and I'm going to try to first I'm going to compare. Oh, I guess I can do that. I'll compare this answer with the data. Let's see if I can compare it with my new data here. And if I show sample output using the preceding input, I get that. And is that the same as this? 2.0. You notice that this is over. This is not the first one. Okay, so I tell you what, I'm gonna try to fix that. I'm gonna, instead of making it the lowest left, I'm gonna make it the lowest right. And I don't need to change the name of this, but I'm just gonna do it anyway. Lowest right, and this is gonna be lowest right, and lowest right is gonna be instead of the point being to the left, if the new point is to the left of the old point, in other words, instead of the low x, it's going to be the high x. So I'm going to say if this new point is greater than low x. So this is going to get the lowest right instead of the lowest left, and we'll see if this works. So basically, instead of this is still there. So basically, I'm going to start here. And I'm going to go around this way. And so the last one should be this one. So this should be the last one. And this should be the first one. Okay, let me save this. And let me copy this again. And I'm going to run this. I get this. And yes, this looks much better. This looks like 2.5, 6.0, 5.5, 1.5, 1. Okay, so now I should be able to go back up to the top here and paste it. This is exercise 1611, and I should be able to paste my code. I'm going to take all my code here all the way down to here, copy, and I'm going to paste that into here. I'm going to do paste. And I'm going to see if this works. Automatic check. Okay, I think the problem is my output doesn't look right. Enter the points, and I say enter the pairs of points, and then I say don't say this. So anyway, you can fix that. You can fix that. So Okay, it turns out that, let me share my screen. It turns out that when you, to be able to get the answer completely correct on project 16.4, your output needs to look like this. This first line needs to say, enter the points in one line separated by space. It's got to look like this. Enter the points in one line separated by space. And then you have to actually print out these coordinates. So I would say print input coordinates. If this was the name of your variable here, this thing, input coordinates. And then you're going to compute the points. You're going to figure out the floating point values for the points are. And then you got to print that out too. So this has got to look like that. That's got to be there. And then you can call, you have to print out this, the convex hull is, and then you have to display out what the points for the convex hull is. So to get all the points in project 4, you have to do like I just did, like I just showed you. But the output for requesting the points for the space, all the points is that request has got to look like this. Then you got to display them out. And then you have to convert them into floating point. And then you need to display that out also. And then you need to print out the convex hull is, and then you need to print out actually the points of that. So make sure you do that to be able to get all the points. This should help you with that problem. It's kind of an interesting problem. There are different ways that we can solve it, and in fact, the textbook has you solve it a different way. If you take the correct answer, once you get it correct here, and you go back to 16.4 programming project, and then you put the correct answer in, it'll say it's the correct answer. It should, and then it'll give you what it believes is the correct answer, which looks a lot different. It keeps track of whether the new point is on the left-hand side or on the right-hand side of the old point, and you have to keep track of whether you want it to be on the left-hand side or the right-hand side. It's a little bit more complicated. But anyway, there are many ways to do it, and I hope you can get this to work, and thanks for watching.